Welcome to the project demonstration of battery management system with temperature protection from overheat and overload. So in this version of the BMS, we added the DS18B20 instead of LM35 sensor. So it is a dust-proof and waterproof sensor, and it can withstand up to high temperature than the LM35. So this is the DS18B20 temperature sensor, so which will come with a 1 meter of probe. So we have interfaced that to the PIC microcontroller at A4 pin. So remaining like voltage sensors for the battery pack 1, battery pack 2 and battery pack 3 interface at the A0, A1, A2 pins, and continuously we are monitoring the battery pack voltage levels. Whenever the respective battery pack voltage level is less than the 10 volts, then the system will on this electromechanical relays, which will provide the 12 volts charging voltage from this charging circuits to the battery. So for the battery pack 1, relay 1, battery pack 2, relay 2, battery pack 3, relay 3. So these three relays interface at C5, C6, C7, and if the temperature is while charging, or if you have any load to the battery packs, if the temperature of this battery pack is increases and when it crosses a threshold value of 50 degrees centigrade, then the system will give the audible alerts through this buzzer, and the so-called status continuously displayed on the 16:2 LCD screen, and the whole system getting power supply from this 230 volts AC input, and that is input to the step down transformer, which will step down the 230 volts AC to 12 volts of AC, but we need to convert that to DC power supply. For that purpose, we are making use of this regulated power supply board. So it has just three stages. The first stage is rectification to convert the AC to pulsating DC, and the next stage is a filtration to remove the pulses and to get the pure DC voltage. For that purpose, we are making use of this capacitor. So that 12 volts DC is parallelly given as the input to the battery packs through this electromagnetic relays, and also parallelly to the 7805 regulator. Why? Because as the operating voltage of our system, including the motherboard, buzzer and LCD relays, are the 5 volt. So we need to regulate that 12 volts DC to 5 volts DC. For that purpose, this 7805 regulator, which will regulate the input 12 volts DC to output 5 volts DC. So then when we provide that, the system start reading input from the 4 sensors. 3 are the voltage sensors and 1 is a temperature sensor, and based on that, these 4 sensors data, it will control the outputs, relays 3 and a buzzer, and the so-called status continuously displayed on the LCD screen. So let us see the demonstration. Just give the 230 volts input to that. So welcome message will be displayed initially, right? So as of now, the temperature is normal, the buzzer in off state only, and the 3 battery packs voltage is normal, it's above 12.5 showing that. So whenever the voltage is less than, so in order to make that, I'm going to disconnect the battery pack 1. So this is going to be the battery pack 3, right? This is a battery pack 3. So then the respective relay will get switched on, so as it's allowing the voltage to the battery to charge it, and when it is sufficient, means when it is fully charged again, then automatically microcontroller will switch off the relay. Same for battery pack 2 also. So same for battery pack 3. So just manually inform the microcontroller about the low voltage by disconnecting the respective battery pack. So coming to the temperature, if the temperature of this battery pack increases, so when it crosses the 50 degrees centigrade, so the heating for the battery packs is due to either over voltage or else over current. So now we are going to protecting that by providing the audible alerts directly. So there are 2 indications. One is the visual indication from this LED and audible indication from the buzzer. Right, when it is normal again, so the buzzer will off state only.